A deer walks up to a murky, stagnant pond, drinks deeply, and walks away fine. You do the same thing, and within a day, you're doubled over with cramps. Same water, wildly different outcomes. It looks like animals must have some kind of superhuman gut we lost somewhere along the way, except that's not actually what's happening. And the real answer starts with a surprising fact about your own stomach. In 2015, researchers published a study in the journal PLOS One comparing the stomach acidity of 68 different species of birds and mammals. The goal was simple: figure out which animals have the harshest stomach chemistry and why. Scavengers and meat eaters, animals that regularly eat questionable, half-rotten food, came out on top with the most acidic stomachs of any group tested. The griffin vulture, which routinely eats carcasses crawling with bacteria that would kill most other animals, has a stomach acidity around pH 1 to 2, acidic enough to dissolve bone. Here's the part almost nobody expects. Humans, despite eating a cooked, relatively clean modern diet, showed stomach acidity right up there with the scavengers at roughly pH 1.5. The researchers suggested this is likely a leftover from a much riskier evolutionary past, a hint that our distant ancestors ate their fair share of questionable, half-scavenged food and evolved a genuinely powerful chemical defense to deal with it. Your stomach isn't some fragile, watered-down version of an animal's. It's already built like a scavenger's. So, if our acid is already that strong, why does dirty water still take us down while a deer walks away fine? Part of the answer is that the deer doesn't actually walk away fine nearly as often as it looks like. Wildlife researchers estimate that somewhere between 80 and 90% of deer in North America carry giardia, the same parasite responsible for the cramping, nausea, and diarrhea that hits backpackers who drink untreated stream water. The deer isn't immune. It's just quietly infected, often for life without anyone noticing, because a limping, subtly unwell deer doesn't get pulled out of the herd and photographed. It just becomes slightly weaker, slightly more likely to be the one a wolf catches, and nobody calls that a water quality problem. Animals absolutely get sick from dirty water. We just don't see most of it happen. But there's a real difference underneath that, and it comes down to exposure. A wild animal drinking from the same pond or stream its entire life, generation after generation, is being continuously exposed to a fairly stable, familiar set of microbes. Repeated low-level contact with that same microbial population lets its immune system build up a working familiarity with the specific threats in that specific water, and offspring get an early head start too, through maternal antibodies passed on before and shortly after birth. It's less that the animal's gut is invincible, and more that its immune system has spent an entire lifetime and often generations training against exactly the germs it's about to swallow. Humans used to have something close to that too. Before modern water treatment, people drank from the same local wells, rivers, and streams their entire community had used for generations, building up a similar kind of regional tolerance. What actually changed isn't our biology, it's our environment. Modern sanitation, chlorinated water, refrigeration, and hygiene have been remarkably good at keeping us alive. But one side effect is that most of us now go through life with almost no exposure to the kind of low-level, everyday pathogen contact that used to quietly train our immune systems from birth. Then, the first time we do encounter something unfamiliar, a foreign country's tap water, an untreated stream on a hiking trip, our bodies have no working familiarity with it at all, and it hits far harder than it would have hit an ancestor with a lifetime of gradual low-dose exposure behind them. There's one more piece, and it's specific to the exact germs involved. Different pathogens are often finely tuned to particular hosts. Vibrio cholerae, the bacterium behind cholera, causes severe, often fatal illness in humans, but doesn't meaningfully affect hippos, even though hippos spend most of their lives submerged in water thick with their own waste and bacteria. It isn't that a hippo's gut is somehow universally tougher than ours. It's that this specific pathogen never evolved the biological keys needed to unlock a hippo's particular cells the way it unlocks ours. The danger in dirty water water was never one universal substance called dirtiness. It's a long list of specific organisms, each one shaped by a long evolutionary history with specific hosts, and humans simply happen to be an unusually good match for several of the nastier ones. Cholera, typhoid, and a handful of others that thrive specifically in us. Put all of this together, and the real picture looks nothing like animals are tough and we're fragile. Our stomach acid is already comparable to a scavenger's. Wild animals get sick from contaminated water constantly. We just rarely witness it. The deer's real advantage isn't a superior gut. It's an immune system trained since birth on that exact pond, something humans also used to have before sanitation quietly removed the need for it. And underneath all of that sits simple bad luck of biology. Some of the deadliest waterborne pathogens on Earth happen to be extremely well adapted specifically to infecting us. We didn't lose some ancient defense animals still have. We built an environment so clean that our own defenses stopped needing to stay sharp. And then we started calling that progress, right up until the one time we drink from the wrong stream.